So we've been talking a lot about both potential and kinetic energy. So potential energy is abbreviated PE and kinetic energy is abbreviated KE. So there is an inverse relationship here that goes on. And the reason is because as you have potential energy stored within an object, eventually that energy is going to be used or released and transformed into kinetic energy. So there's two main types of energy. One transforms into the other. So if you're starting with a lot of potential energy, I'm doing this in this case because it's up higher, then you're going to have very little to no kinetic energy. But as you release this potential energy, so let's say this is an object dropping, then it's going to push the seesaw down, and eventually there's going to be a halfway point where both of these energies are equal. And then as this one gets to the bottom, it's going to have zero potential energy, all of its energy converted and transformed into kinetic energy. So an inverse relationship, opposites. So if you take a look at this car has weights on it and it's on a hill. So what you're looking at here is both types of kinetic energy. So when it's at the top, you'll notice that the blue is already at the top. But then as it's let go, then the potential energy is actually converted into kinetic energy. And at some point, right about there, they're equal. So you've got half potential energy, half kinetic energy. This is total mechanical energy, so there's always, in this case, it is a perfect system. They're accounting for no loss of energy, so therefore it's always going to be 100% between both the kinetic and the potential when you add them up. Okay, same thing here, but no animation. There's a soccer ball at the top. There's 100% potential energy, 0% kinetic energy. How do you know that? Because, well, in this case, we're going to assume that it's not moving. But once the ball starts rolling down, and you'll see it's about roughly a quarter way down the slope, so therefore there's about a quarter of the potential energy lost, and a quarter of it has turned into kinetic energy. So that energy's already been transformed into moving energy. So now about halfway down, the stored energy is about half, and the kinetic energy is about half because that upper part, that top percentage, 50%, has already gotten converted into moving energy. At the bottom, then the potential energy is all gone. It has no ability to speed up anymore. All of its energy has been used, and therefore its kinetic energy is at 100% at that moment that it gets to the very bottom. I'm going to show these in class. Here's a roller coaster where you've got some differences going on. There's two scenarios here. The first one is this one on the top where the roller coaster is at the top. It's going to have lots of potential energy. You're going to notice that as it goes down, the kinetic energy goes up, potential goes down, but yet then they reverse again because now you're lifting the object off the ground and then it comes back down again. So there's always this relationship, this inverse relationship. And the energy, it's assuming that in this scenario, none of the energy is being lost. Down below, same thing here. We've got lots of potential. It releases, and you get lots of kinetic. And so we've got that inverse relationship occurring. And that's it.